Determine the sum to n terms of the following series. Okay, let us begin. Now, our first task will be to find out the rth term of the series. Now, let us suppose that TR represent the rth term of the series. Now, how do we find out the rth term? So, what we'll do, in each of the terms we say the numerator is simply 1. So, we'll keep the numerator as 1. Now, let's consider the first term in each of the denominator. So, here we have 1. Then followed by 4, then we have 7, and we clearly observe that this particular sequence of numbers are in arithmetic progression, with first term being 1 and the common difference being 3. So that means we can easily define its rth term as a plus r minus 1 times the common difference d. So here we have 1 plus r minus 1 times the common difference, which is 3. So that's going to give us 3r minus 2. So we have 3r minus 2 in the denominator. This is going to get multiplied with, now we see that the second number in each of the denominator that starts with 4, and then we have 7, then followed by 10, and the remaining terms, which means that these terms are forming an arithmetic progression, with first term being 4 and the common difference being 3. We can also define this rth term as 4 added to r minus 1 times the common difference d. So that means we have 3r plus 1. We're going to substitute this. We have 3r plus 1, and this clearly is going to be the nth term of the series. However, what we'll do, we'll decompose this into two partial fractions. So let's say we take 1 over 3r minus 2, and from here we're going to subtract 1 over 3r plus 1. However, if we combine both of them, then we are going to get 3 in the numerator. So we have to take care of that. All we have to do is multiply with 1 over 3. So that takes care of the 3 in the numerator portion. Now that we have the nth term, the rth term of the series, we are ready to find out the sum to n terms. To find out the sum to n terms, all we have to do is take the summation of the rth term of the series, which is 1 over 3 multiplied to 1 over 3 times r minus 2 minus 1 over 3 times r plus 1, with the index r going from 1 to n. Now what we'll do, we're going to expand this series. Our first term will be 1 over 3 multiplied to, we're going to replace r with 1, such that we get 1 over 3 times 1 minus 2, so that's simply going to be 1 minus 1 over, so 3 times 1 plus 1, so that's going to give us 4, which means we have 1 over 4. This is going to get added to the second term. So we have 1 over 3 multiplied to. So 1 over 3 times r will be replaced by 2. So we have 3 times 2, that's 6. 6 minus 2, that's simply 1 over 4. Minus 1 over. So 3 times 2, that's 6. 6 added to 1, that's 7. We have 1 over 3, the third term, that's going to be 1 over 7 minus 1 over 10. Then we have the rest of the terms coming to the last term, which is the nth term. We're going to replace r with n, so we get 1 over 3n minus 2 minus 1 over 3n plus 1. Okay, now immediately when we take the sum, we observe that the second term and the third term cancels out. The third term and the fourth term cancels out, which means that the fifth and the sixth term will get cancelled out. The second last term will get cancelled out with the third last term, which is going to leave us with 1 over 3 multiplied with 2, the first term minus the last term, 1 over 3n plus 1. So let's combine them. So that's going to give us 1 over 3 multiplied to 3n divided by 3n plus 1. So we can factor out the 3 from the numerator and the denominator, and therefore we have the final sum. Thus, the final sum as n is going to be equals to n divided by 3n plus 1. So this is going to be the sum to n terms of the given series.